Hi, welcome to another mini lecture on pre-calculus. Today's topic is coterminal angles. What are the coterminal angles? We said when we are dealing with measurement of angles, we have a standard to follow. We start on the x-axis and going counterclockwise is positive, going clockwise is negative. Now, the issue that comes up is that you can end up rotating several times in positive or negative direction and stopping at some location. So suppose I tell you I went around this track and this is where I stopped. Well, you cannot tell how many times I went around the track and in which direction I went. You only know that stopping place. So if two people meet on the track, the amount of walk they have done is not necessarily the same. It's just that they met. In that case, we say they are coterminal, meaning they are starting at the same location, they have ended up at the same location, and the angles that they traveled are going to be called coterminal. For example, if I just simply go from here to here, okay, that would be easy. If instead I go turn around an entire circle and then come back to this location, then the red and the green are going to be called coterminal. To make the matter worse, a third person could travel this way and end up at that location, and that one is also coterminal with the first two. So there are in fact infinitely many ways of arriving at the same location, and all of these angles will be coterminal. Now we want to extract something useful, which is what angle between 0 and 360 degrees or 0 and 2 pi is coterminal with a certain angle. So let's start with a simple one. Let's go after the degrees first. Suppose somebody has walked 1260 degrees. So we understand this is positive, so this person has gone on a circle. Okay, one full circle by now is 360. Well, he doesn't stop, he continues going, and the second circle by now is 720. Well, he doesn't stop there either. It's going, and a third circle becomes 1080 degrees. We see that there is not that much left to make another circle, so he goes somewhere and stops. We don't know exactly where he's going to stop, at what angle. He goes up to 1260 degrees. Well, what's the extra he is traveling on? Well, this was the first round, second round, third round. On the fourth round, how much extra is he going? So I take 1260, subtract 1080 from it, so that's 180 degrees. So he has actually come all the way to here, and that's where his stopping location is. So the angle that is in 0 to 360 and coterminal with his location is this angle of 180. So a simple way of finding the answer in these cases, if the angle that you have is a positive angle, typically large positive angle, what do? You keep subtracting 360 from it, so 1260 degrees. If you wish, subtract 360, so you have like 900 left. That's still more than 360. Subtract 360 from it, So now you have what, 540 degrees left. That's still more than 360. Subtract 360 from it, you have 180 left. That is the angle between 0 and 360 that's coterminal with 1260. If you want to have a formula, not recommending a formula, but just in case you want to have one, suppose you are given an angle A, you have to keep subtracting. Is that right? How many times do you subtract? Take your angle, divide by 360, and just keep the whole part. Whole part meaning throwing away fractional part. Sometimes they write it like this. They call it the floor function. Floor function. So we take our angle divided by 360, throw away the fractional part, just keep the whole part. Whatever this thing is, how many times you're going around the circle. Multiply that by 360, so you know how many degrees that's gonna be. That's like obtaining 1080 by now. When you subtract it from your original angle, you see what is left, and that is your final answer. So if you want the formula, this particular notation sometimes called floor function. Floor function, those of you who are going to be, well, most disciplines are going to use this thing, more commonly used in computer science, but either way it just simply means keep the whole part. So if you have like 1260, we want to subtract from that 1260 divided by 360. That's going to be 3 times 360. So this is going to be 1260 minus, this is 3 times 360, meaning you're going around the circle 3 times. So 1260 minus 1080, you get 180 degrees. So here's a formula in case you want to have a formula, but not really necessary. Same issue, well, a bit more complicated with radians, because the numbers are not whole numbers and lots of pi's all over the place, and the angle is also negative, minus 19 pi over 10 radians. You might find easy ways of getting the answer without going through the steps that I'm going to mention right now, but just to give a general recipe. Okay, so we are after a general recipe. An angle is given to us, is in radians, and it's negative. What do we do? Well, if the angle is negative, it means we are traveling this way. Is that right? 19 pi over 20 is almost minus 20 pi over 20, which is almost like minus 2 pi, which means this person has gone almost a full circle. It's just a little bit short. How can we figure it out? How short it is? Just add 2 pi to it. So 2 pi, the original angle was minus 19 over 10. Okay, now you have to be comfortable taking common denominators. So this is 10. 10 multiplies by 2 pi becomes 20 pi minus 19 pi, and that becomes pi over 10. So the angle that is left here is really this, that's pi over 10. As soon as you get an answer less than 2 pi, you are done. So that is, we got the answer here quickly, as opposed to the other one that we had to go through 3 rounds. So simple way of doing this problem, keep adding 2 pi's to it until your answer becomes positive, and then that's it. If this angle was positive and you want to go in the opposite direction, let's see if the next example is of that type. Unfortunately, it isn't So suppose I had like 31 pi over 10. What do I do? So if the question was I have an angle of 31 pi over 10, what's an angle between 0 and 2 pi that's coterminal with this one? If you start with a positive, you subtract 2 pi from it until it comes down. You essentially cut it down to size. So common denominator is 10 again, 31 pi minus 20 pi. So that's 11 pi over 10. Notice that it is just slightly more than pi, and that is going to be our final answer now, that the angle coterminal with 31 pi over 10 is just 11 pi over 10. You can make a formula like this one as well, but let me leave that to you. Or if you are interested, just call me and we are going to talk about that. Between 0 and 360, find an angle between 0 and 360 that's coterminal with 1170. So again, we said easy way, keep shaving off of this until you are in the range you want. So way that doesn't require any formulas and such, you just subtract, you get what, 810 degrees, still more than 360. Subtract again, so 5 and this is 450, and subtract again, and then finally come down to a recognizable angle. So 1170, it means we had gone through circle 3 times. So it was a situation like this: you went once, you went the second time, you went the third time. This is 3 rounds, and this is the final stretch for you. That's extra 90 degrees. The angle that's coterminal with this is just that angle, which is the 90-degree angle. How about minus 3 pi? This one is easy. Well, add 2 pi to it. You're still at minus pi. This is still not in the range we want. Add another 2 pi to it, and now you get pi. The final answer is pi. What's the meaning of this problem? Minus 3 pi. So you went minus pi, minus 2 pi, minus 3 pi. That's where you went. You want to bring it in 0 to 2 pi. Say, okay, I want to travel in this direction, and that is where I'm going to stop. So the angle answer becomes pi. Okay, good luck and God bless. Until next time.